So my sessions today is about satellite IoT making smart cities, making cities smarter. So you can see on the first slide, Kinesis constellation. So as an expert, as per the introduction, so I've been working for 20 years for Good Power, which is a company based in smart grid solutions, and I've joined Kinesis in 2020. Kinesis is a satellite connectivity provider, so we supply a full solution for dedicated to IoT and IoT connectivity. So a little bit about Kinesis before starting entry into the topic of smart cities is that Kinesis is a satellite operator supplying global IoT coverage. So we have today 9 satellites flying, supplying a global coverage worldwide. So we can pick up information from any spot you are on Earth. We're typically dedicated to IoT, so that's very nice for today's sessions. It's typically like an LP1. It's low power consumption, low data rates, and low cost. We supply a latency to pick up the information from any place on Earth in less than 15 minutes from 2023. We can do hybridization with the terrestrial connectivity suppliers. I will enter into the details a little bit later because it's very convenient for smart cities. And we also have two-way communications, which means that you communicate with the devices and the sensors wherever they are hosted worldwide. And we typically operate in a frequency range of 400 megahertz, which is US band, which has a very good penetration also, and allows us also to communicate in urban areas. And the fact is that we don't need the directivity of the antenna. We are omnidirectional, which is very helpful in cities when you have buildings around. So a little bit about our background. We come from the CNES, which is the French Space Agency, and so from CLS, which is one of the main shareholders. So they have been collecting since the early 80s already data that's way before the existence of the GPS. So that means they have been collecting data for environmental and scientific use. In 2020, we had a 100 million euro fundraising, and we are belonging to the next 40 since 2021 and 2022, and we're a member of the French technology. So why IoT via satellite? So today, everybody's talking about several billions of connected devices between now and 2030. But in the end, you only have 15% of the world surface that is covered by terrestrial networks. So if you look at the map on the slide, which is the data from ITU, data research, you can see you have these major areas worldwide that are connected, but there are still a lot of areas without any connectivity worldwide. So the United Nations, they expect that by 2025, 65% of the world population will live in cities, driven by the growth of mega cities. But as you can see the figures on the slide, the growth of the population within cities is not really expected in the areas we would thought about, all of us. They're rather not in Europe, not in North Africa, and not in North America, but you can see that the major cities are either in Asia or in Africa. Which means that there are a lot of networks still to be rolled out worldwide. And when you roll out terrestrial networks, it's a huge amount of money that needs to be invested. And the advantage of satellite is that the infrastructures cover straight away the full globe without deploying any expensive terrestrial networks. So market snapshot of satellite IoT and the different players worldwide. So The revenue is expected to be $1 billion by 2026 for satellite IoT. You see the major satellite operators, they have all an IoT offering today available. It is LEO and GEO, but they are completely complementary to the actual terrestrial coverage and other telecommunication rollouts. So what we really think is that today the winning combination for smart cities and IoT rollout is combining different technologies to offer a seamless and global coverage. The advantage for satellite serving cities is that comparing to terrestrial networks is that satellite infrastructures, they remain operational during disasters like tsunamis or tornadoes, etc., because you just can't destroy the infrastructure when there is a natural disaster somewhere. And it will, in any case, allow emergency services through satellite connectivity. Today, the other advantage of satellite IoT for smart cities is that it is the only technology offering a global coverage. You can imagine, for example, cities that are very, very huge geographical coverage. Probably if they roll out today fiber networks or 5G or any other technology, it will still be limited to the heart of the city. And when the city is stretched, they will probably never roll out fiber in every single spot of the city. We think that globally, for cities, a network of networks will serve the biggest cities in the future. You can see the combination is perfect between both. You can have the terrestrial, you can have the satellite, and they will be combined on the same operator's platform, which means that for the user of the data, there will be only one channel out in the end. For smart cities, there is a whole range of applications today. So if I speak about the smart city, it's really about the infrastructure we're talking about. So Kineis, as a satellite operator or any other satellite operator, will not be efficient for applications like smart building, because due to the fact that the satellite needs to have a site to the satellite, we are really linked to everything that's linked to outside applications and also infrastructures. So some of the smart city applications would be smart mobility. So in the smart mobility, it's everything that's linked, for example, to autonomous cars, electrical vehicle charging, smart parkings, everything linked to mobility. And the advantage of satellite connectivity at that stage is also that is when the mobility goes out of the smart city, it will remain the global coverage. So if you are moving things around, that means that you will not have any interference and any stopping of the tracking due to roaming issues or areas where there's no coverage as soon as you get a little bit out of the heart of the city center. Another use case for smart cities, everything that's linked to emergency and safety. So today it's already existing that every single emergency system worldwide has a satellite backup, just in case if there is any failure on the terrestrial network. Of course, a big advantage of satellite technology is for smart grid management. So everything that's linked to smart grid electricity, water, smart water applications, and gas. Satellite IoT is really an advantage, because you can roll out the same technology wherever you are, inside the city, outside the city, using the same quality and same technology. Another thing is the air quality, which is really a big issue today in smart cities. You can have IoT sensors that collect, you can have a gateway and then collect all the smart sensors of a city and push the data through satellite technology. And then the last one is waste management. So if you see that the cities are getting bigger and bigger, you can have connected waste bins or waste collection, which goes through satellite connectivity. So I gave just some examples to show you that I really think that satellite IoT has a place in smart city applications and can be used in combination with other existing technologies like 5G, 4G, or LTM or NB-IoT. And the satellite can be used as fallback if any of these original connectivity technologies fail, which may happen in some cases. So satellite connectivity is really a truly global technology, and it covers really every single place on Earth. So you have no blind spots, no roaming issues between the different telco operators, and you don't need any expensive and vulnerable private network investments. And if you have seen on one of the first slides that most of the biggest cities and the extension of the biggest cities are outside of North America or European, which are really well covered today, I think there's really a place for satellite IoT to play in this kind of technology for the next coming years. So what exactly brings satellite-based IoT connectivity for smart cities? So it brings you IoT everywhere. So no blind spots, no blind areas, no roaming. It covers every single spot on Earth, wherever you roll out infrastructures. You can track and locate with native location service. It means that by satellite passes, you can locate specifically a device without using any GNSS technology like GPS or Galileo. You can collect typically data of 30 bytes, which are compatible with all existing IoT sensors on the market today. There are alert systems. So that means that, for example, in a city, you can give an alert if the temperature or the air quality gives you an information that you would like to use as an alert, for example, on the air quality in rush hours in the big cities. Device control. So you have two-way communication. You can update, for example, at which level you would like to start an alert from a specific device, which may be water control, air control, temperature, shock. You can imagine that, for example, on infrastructure monitoring, you could have an alert on inclination, motion, which is not usual on any of your infrastructure installed inside the city. And the last, really the key arguments, and I spoke about it early on the slides, is I think really that the future of IoT and also for smart cities is a network of networks. It's the combination between the different players, between satellite operators and historical telecom operators, and combining different technologies gives you the guarantee to get the information and the data all the time for the customers. The native accuracy today by satellite passes, it's in the chat. Roughly today, it goes from 100 meter to 1 kilometer, depending on the number of messages you collect on the same device. So it's done by the number of satellite passes, and they can make a specific algorithm with a calculation in the back. So it goes from 100 meter to 1 kilometer, depending on the area and the number of messages that are collected by the device. So satellite IoT technology allows you today to get your data within 15 minutes from a very, very small device. For us, the smallest device today is half a thumb, and it's 0.05 grams only, and it's the smallest device we have in our product range today. with a minimum of power. For example, it's quite amazing because today with a very small chipset, and an antenna, which is very compact as well, you can transmit information to an infrastructure that is 650 kilometers above your head. That's like sending with a small antenna information from Paris to Marseille, for example. And this minimum power for transmission gives you a maximum autonomy, which means that devices that you will roll out worldwide can have an autonomy today without any power recharge or battery recharge between 5 and 10 years. So I would like to thank all of you for participating today. I kept 10 minutes for your different questions. So please feel free to drop your questions either in the chat or directly.
Perfect, wonderful. So thank you again, Astrid, for this insightful presentation, and it really shows how the power of the space technology when we're talking about, you know, applying it to cities and for the Earth application for the benefit of, again, the improving the quality of life or the way that we generally run the processes, right? So
yes, I think there is really a topic of sustainable cities today, and there, of course, satellite IoT is very helpful.
Yes, absolutely. So once again, the audience can drop their questions in the chat, and while they will do so, I will ask you several questions from my side, Astrid. So one of my questions will be, again, as you were talking about autonomy, right, and minimal power. My question to you will be, how do you see artificial intelligence being part of this process, and what could be its potential applications to really improve and fully automate, let's say, this process to the degree that it's possible to automate it?
Yes, of course, it has a big role in upfront analyzing already the situations before even sending the data out to the satellite. I think there are two main topics. It's artificial intelligence. So we imagine upfront, and we compute already information upfront before sending the data to the satellite and back to the customer. And there's another big topic, which is what we call the computing of the information set. Of course, I spoke before about the typical messages that are between 30 bytes and 90 bytes, which means if you are doing any fallback satellite technologies, is that there is some artificial intelligence and computing upfront to keep the information as useful as possible and as compact as possible to have the earliest customer feedback as possible.
Mm-hmm. Wonderful. So thank you for that answer. So meanwhile, Mikhail has a question to you. How would your customers pay you? One-time fee when they buy the modem, or subscription fee, or any other? So the pricing model is that.
So very clear. So our go-to-market strategy is we work with value-added resellers. So that's people that value the data for the end user by combining different applications, and they value most of the time also with other technologies, and we integrate Kinis connectivity into devices from value-added manufacturers. So Kinis is a satellite operator. We're like a telco. Instead of our infrastructure is 650 kilometers above your head, so we supply connectivity and we supply electronics to communicate with our satellites. The price model looks at the following. There are several ways the people pay us. The first is the services is based on the number of messages per device per month. On top, you have different other service options like downlink, acknowledgements, native positioning. And then the other option is for big distributors, they can buy a pool of data or a pool of number of devices, and they host their own activity inside depending on the number of devices. And we say a huge package of capacity with a number of messages that we estimate upfront per month. So it's a monthly subscription people have with our company, and this depends on the data they use and the number of devices they have inside their network.
Wonderful. So perfect. Thank you for that answer as well, Astrid. So my next question is, now with the proliferation of the IoT devices and the increasing importance in today's life of the data privacy, right? So what measures is Kines taking to ensure that the security of the data transmitted by its satellite network?
Okay, very clear as a question. So for us, the first big advantage is that we are a satellite operator, but we operate the full system ourselves. So that means the satellites are ours. We operate the satellites ourselves. We have 20 ground stations hosted worldwide that are ours. They're all the same, using the same equipment. And on the communication part, the link between the device and the satellite, and the satellite back to our ground station, and the ground station to our service center, which belongs to us as well. The information is, of course, encrypted, protected. On top, we also offer a second encryption if required by the end customer, that even Kines cannot access. That depends on the customer requirement. And of course, I think in Europe, we have the most advanced RGPD data protection law that's already in place, and we're fully compliant with this law, of course.
Wonderful, perfect. So, and the last question probably for today from my side, Astrid, will be, so what do you see next as coming up in the IoT sector? So what will be this new innovations, and what are some of the challenges currently that are preventing us from achieving those breakthroughs?
So the next steps on IoT is definitely what we call massification of the rollouts. I think until now, where we have seen big successes of IoT is in smart buildings and smart cities. That's why we spoke about smart cities today. But there are definitely many other opportunities that still are in early stage POCs, and on which all the IoT operators expect massive rollouts in the coming years. So I give you some examples. It's like a smart logistics and transport. Another thing is infrastructure and network, in which you have definitely collaborations with historical telecom operators. It's on the maritime sector as well. Historically, there's a lot of broadband, but there's not a lot of IoT yet. But on the maritime, you can imagine monitoring leisure boats and giving the information about their battery levels, water storage on board, positioning, and all kinds of other sensors the vessels have. And one of the big, I think, future applications is also smart agriculture, in which you will find optimization of the crop management, smart weather stations, livestock management. So there's still a lot of challenges to be tackled to have massive rollouts on IoT on other segments than smart building and smart cities.
Perfect. And how do you see the competition that's currently growing playing the role in terms of becoming, in terms of the advancing the field? So how do you see the competition playing part in that?
So the competition, there are a lot of players on satellite IoT today, and that's, I think it's also because it is definitely one of the future big, let's say, market rollout. So I always say, the more competition we see, that means that the market segment is interesting. So that means there are a lot of volumes to be done in the next coming years.
Perfect, wonderful. Yeah, because we see also a lot of those newer companies now, the startups, they're focusing on the name is Pico satellites for IoT applications and for the Pocket Cube fleets that they're developing. So how would that differ, Astrid, from, let's say, your satellite fleet? So how would that differ?
Okay, so our satellites, we have the advantage that our solution is based on 40 years of experience. So we are a startup without really being a startup. Our satellites are a little bit bigger. It's a 26U. They're roughly between approximately 25 kilos, which means that Kines, with 25 satellites, we are able to pick up the information worldwide in less than 15 minutes. So it's a polar orbital plan. So on the poles, you're in real time. And the worst case is on the equator, where you have 15 minutes latency. Comparing to the other players that launched the satellites that are much smaller, that means that they need to launch many more satellites to get the same service as Kines with only 25. And this is also due to the fact that within Kines we have people that have 30 years of experience from the CNES. So we have really high skilled people internally and great technical teams. So that's a little bit the difference. Most of the time we also get the question about, okay, Kines versus Starlink, OneWeb, etc. So we're definitely not a mega constellation dedicated to supplying broadband services and internet via satellite. Our constellation is really dedicated to IoT only, which is small messages, low power consumption, comparing to the mega constellation where the equipment is still quite big, and it needs a power supply to get the communication system done.